Hello, good day, pre-algebra. We are here with you going over the C017 quiz, what was assigned to you to do yesterday, kind of recapping C017, obviously. That's why it's called C017 quiz. We'll then go over the PO18 homework, dive into PO19, and you will again have a quiz to complete for me as part of your homework, just so I can kind of see where things are at and what we need to review or do over again or whatever. So just briefly talking about this quiz from yesterday, it was 3 questions. And basically your answers were yes or no for all of them. Is n equals 6 a solution of 4n minus 14 equals 10? And so to determine whether or not n can be 6, we're going to rewrite the equation that we have with 6 plugged in for n, right? Because that's what we are testing. If n can be 6, then 4 times 6 minus 14 is going to equal 10. And 24 minus 14 does indeed equal 10. So this would be yes. Fill in that bubble completely, just like we learned in our standardized tests. You're actually probably too young for you. Remember those fill in the bubble standardized tests. You are missing out. Let me tell you what. But that's basically the gist of C017 here. Is n equals 8 a solution of 15 minus 2n equals 1? Well, let's test it. 15 minus 2 times 8, just replace n with 8. We want to know if that equals 1. 15 minus 16 is negative 1, which is not equal to positive 1. So this one does not work out. 8 is not a solution. Those of you that when your scores came in, and I could kind of see that especially numbers 2 and 3 with those negative signs, that those were the ones that you got incorrect. That kind of tells me that you've really got to pay close attention to negative signs, where they are, what they mean, how they affect the equation. Because I can almost guarantee, 15 minus 16, you rearrange those perhaps, thought 16 minus 15 was the same thing, or maybe you didn't see the negative sign. I don't know, but there we have it. Third one, is n equals negative 5 a solution of 4n plus 3 minus 2n equals negative 7? If we don't combine like terms, we get 4 times negative 5 plus 3 minus 2 times negative 5. And we want to see if that equals 7. Just for each n in this equation, we're going to replace it with the value that we're testing, negative 5. So 4 times negative 5 is negative 20 plus 3. And then remember that this sign belongs to that 2. So it's a negative 2 times a negative 5. And a negative times a negative would give us positive 10. Positive 10. So negative 20 plus 3 is negative 17. And negative 17 plus 10 does equal, see, here I forgot the negative sign. See how easy it is? Negative 17 plus 10 does equal negative 7, what is what we want. So this one is a yes as well. If you combine like terms first, which is acceptable here, you've got 4 n's, you subtract 2 of them. That leaves you with the equation 4 minus 2 is 2n plus 3 equals negative 7. Again, plugging in negative 5 for n here. 2 times negative 5 is a negative 10. And negative 10 plus 3 does equal negative 7. So if you combine like terms first, you still get that yes result. But I think it was that negative sign, that minus 2n, with n being a negative number, that really threw some people off there. So just take your time, show your work, pay attention to the order of operations, the rules that we've talked about before, PO10, and just work through it step by step. Okay, so that's how we got the yes, no, yes combo here. For those who did give me some feedback down in this section, okay, thank you. This will be at the end of every quiz that you have, whether I'm here or not. But any questions that you have, put them here. And I responded directly to those people that had questions, and I will continue to do that. So thank you, thank you, thank you. Okay, done with this. Let's go on to PO18, your homework. And you were required to use opposite operations here. And so I'm going to show you up on the board exactly what I expect you to have on your paper. This first one, n minus 7 equals 20. Opposite operations tell us to subtract 7 from both sides. N equals 13. And then we check that by plugging 13 back in for n. 13 plus 7 equals 20. Yes, it does. Okay. I'm not going to show the checking from here on out just to save myself a little bit of time, but do have that on your own paper, and it doesn't take very, very long. And as you saw in the lesson video yesterday, when I did make a mistake, that I was able to catch that because I checked it. 15 plus n equals 25. I want to get n by itself. I've got a positive 15, so the opposite of that is subtracting 15. I'm left with n equals 10. And 15 plus 10 does equal 25. Next one, n plus 21 equals 36. The opposite of adding 21 is subtracting 21. N is by itself because those cancel out, right? That's why we do opposite operations, is get the variable alone. 21 minus 21 equals 0. And 36 minus 21 is 15. And 15 plus 21 does equal 36. Second row, I've got n minus 18. Now the first three were all kind of similar in that they involved addition. Now our original equation involves subtraction. And the opposite of subtracting 18, the opposite of a negative 18, is adding 18, right? What makes 0 from negative 18? What's the opposite of negative 18? Positive 18. So add 18 to both sides. On the left side, they cancel out, which is what we want. And 22 plus 18 equals 40. If we plug that back in to check, does 40 minus 18 equal 22? Yes, it does. Second one, n minus 11 equals 6. The opposite of subtracting 11 is adding 11. And we have to do it to both sides to keep that equation balanced, right? N equals 17, 6 plus 11, and there we have it. Last one in this row, n minus 4 equals 48. Opposite of subtracting 4 is adding 4. Do that to both sides. N equals 52 for that row to finish it out. All right. I will scroll down to the next section here. Here we kind of throw in some negative numbers here, some different operations, okay? Really stretch that brain a little bit, I hope. So n plus 10 equals 4. And also this, some of you, your mental math ability is a little bit less accurate when we start involving negatives, which again, why showing that work, showing the opposite operations can help to avoid those mistakes that inevitably get made when you try and solve an equation mentally. The opposite of positive 10 is negative 10, or subtracting 10. 10 minus 10 is 0. 4 minus 10 is negative 6. Negative 6 is your answer. The next one, n plus 9. The opposite of adding 9 is subtracting 9. On the left, they cancel out. 9 minus 9 equals 0. And on the right, negative 14 minus 9 equals negative 23. Negative 23. Then the last one in this row, n minus 5 equals negative 2. The opposite of a negative 5 is a positive 5, or the opposite of subtracting 5 is adding 5. Negative 5 plus 5 is 0. Negative 2 plus 5 is positive 3. Positive 3. And of course, checking these, if I plug 3 back in, 3 minus 5 does equal negative 2. Negative 23 plus 9 does equal negative 14. They all check out. In the last row, negative 12 plus n equals 10. Well, this one's a little bit different than some of the ones you've seen before, that variable term coming second on that left side. And so we are adding n to negative 12, but it's a negative 12 that we want to get rid of because we do still want n by itself. So the opposite of a negative 12 is a positive 12. And that's what gives us 0 here, right? Because negative 12 plus 12 equals 0. N is by itself, and 10 plus 12 equals 22. If you check that, negative 12 plus 22, that does give you 10. Same situation here. We want to add 9 to both sides to undo that negative 9. N is by itself, negative 6 plus 9, positive 3. And last but not least, n minus 8 equals negative 28. The opposite of a negative 8 is a positive 8. The opposite of subtracting 8 is adding 8. Either way you think about it, we're going to add 8 to both sides to get that n by itself. And negative 28 plus 8 is a negative 20. Negative 20. Okay? Jot down any notes that you have here. And all of these equations that we did here on PO18 are called one-step equations because there was literally one step needed to do to solve them. You had to add something to both sides, subtract something from both sides, and that's all that was needed to get n by itself. So one-step equations involving addition and subtraction here. The two word problem is down below. The number of baseball cards in a limited edition collection is 100, and you already have 36. How many more cards do you need to complete the set? So this one, you don't really need an equation per se, but it's just a real-life one-step equation example. Okay, you could set it up to be 36, the cards that you have, plus C, the cards that you need, equals 100, the total cards in the collection. Right? That's how you would set this up as a one-step equation with a variable to solve for. And to do this, you subtract 36 from both sides, right? Now you probably just took 100 minus 36 to start with, right? And that got you the answer, 64 cards left. But the reason why you're allowed to do this is because of the way it's set up here. Notice that in this way too, we're still taking 100 minus 36. Okay, you probably skipped this step and went straight here, which is totally fine, right? But either way, 64 is the answer. Today it is negative 3 degrees, and tomorrow will be negative 11 degrees. No, say it ain't so. How many degrees colder will it be tomorrow? So for this one, maybe an equation didn't really help you, but looking at a number line, you know, because in Minnesota we're familiar with thermometers with negative temperatures on it. If it's negative 3 degrees today, and tomorrow it'll be negative 11, you know, how many jumps is it? 8, right? To get from negative 3 to negative 11. Okay. As an equation, you could say that negative 3 minus n equals negative 11, and n would be 8 there. Negative 3 minus 8, right, equals negative 11. That would work. But most of you probably in your head, either on paper or in your head, just kind of counted from negative 3 down to negative 11, and it's 8 degrees colder. You wouldn't want to say, your answer shouldn't be negative 8, you know, because how many degrees colder will it be tomorrow? Negative 8 degrees. You don't really say it like that. It's 8 degrees colder. That word colder kind of implies that, you know, we're going further negative. So if you put negative 8, I wouldn't mark it wrong, but just know that grammatically saying it's going to be negative 8 degrees colder isn't really what we say. It doesn't really make sense. Okay? All right, on your quiz today, which will include questions from PO18 and PO19, actually. If you've got further issues, further things that you're confused by, please do let me know in the quiz. So, on to PO19, solving equations with multiplication and division. We are still in our one-step equation realm here, only now the operations that we'll be working with are multiplication and division, rather than just addition and subtraction. And the reason why we're moving up, you know, think of everything goes back to PERMDAS, right? We started with addition and subtraction. Now we're moving up a level. We're talking about multiplication and division, which are opposite operations. There's that phrase again, right? Opposite operations. So just like before, we're going to kind of ignore this fact families. Oops, not a star. I meant a giant X. That fact families section there, and really focus on opposite operations, but also talk about logic. Okay. Logically, what is this equation telling us? 8n equals 32. It's 8 times what number? Right? 8 times something is 32. What is that something? What is that number that when you multiply it by 8 will give you 32? And already you probably mentally solved this to be 4. I'll give my warning here, right? Those of you that really are just doing this mentally and not going through the steps that I'm going to show you to solve this at one step. I'm only asking for one. When we get to equations that you're not able to solve mentally, and they're out there, I promise you, you've got to have some sort of process. And that's what I'm teaching you here, okay? Opposite operations with 8n equals 32. The opposite of multiplying is dividing, right? What are we doing to n here? We are multiplying n by 8. So to get n by itself, we want to undo that operation. So we are going to be dividing both sides by 8. And you might be thinking to yourself, okay, but how does that get the 8 to cancel out, right? Like with addition and subtraction, when we added something or subtracted something, we always got 0. We don't get 0 from 8 divided by 8. What do we get? As if an empty classroom's going to answer here. 8 divided by 8 equals 1, right? What this is saying is that 8 n's, whatever n is, 8 of them give us 32. We want to know what 1 n is. Not 8 of them, what 1 n is. So the fact that 8 divided by 8 equals 1 n is exactly what we want. So when you multiply and divide here, you're not going to get these to cancel to be 0. You're going to get them to cancel out to be 1. Because that's how many n's we really care about. Okay? And 32 divided by 8 equals 4. All right? Some more examples with this. I'll give you a moment to jot down notes. Sorry, I was told that I go a little bit too quickly when I'm just up here teaching. So I'll slow it down, give you a chance. Okay? All right. Using all 3 methods from above, note we're only going to be using opposite operations here. But we have 9n equals 117. Now what this is saying is that whatever n is, 9 of them make 117. 9 n's make 117. Do we care what 9 n's is? No. We want to know what 1 n is. So the opposite of multiplying n by 9 is dividing by 9. 9 divided by 9 equals 1, which essentially means that they cancel out because that's what we want. We want to know what 1 n is. And 117 divided by 9 is 13. Quickly check my math on that. Yes. Okay. So 9 times 13 gives us 117. The next one, n divided by -5 equals -10. Now, it might help you to go ahead and write this instead of as a fraction like that, write it horizontally here, right? N divided by -5 equals -10. Just to remind you that that fraction is, in fact, a division symbol. So that what's the opposite of dividing n by -5? Well, the opposite is multiplying by -5. And here's one of the few instances when you'll see me use the x to refer to multiplying. It's not x minus 5 here, it's times -5. But if I put like a dot -5, I don't know, maybe Maybe you know that, man. That would make sense there. But in any case, dividing by -5, the opposite of that is multiplying by -5. So -5 times -5, they end up canceling out. N is by itself. -10 times -5 is +50. Okay. Now, wrapping your head around an equation like this is a little bit more difficult than the first one here, because what I said was -5 times -5 cancels out. Well, -5 times -5 is really +25, isn't it? -5 times -5. So how am I able to cancel them out here? Well, what's really going on, if we leave this written as a fraction, n divided by -5, if I multiply this by -5, which as a fraction is -5/1, we've learned how to cancel within fractions before, right? Can't we cancel out going crossways? And we're left with n/1, or just n. So when I say -5 times -5 cancels out, I'm talking about this -5 being in the denominator of the first fraction, and then the multiplying by -5 being in the numerator of that second fraction. If you didn't cancel out, if you're like, I don't remember talking about canceling out like that, that doesn't make any sense to me, okay? If we've got n divided by -5 and we multiply by -5, well, our rule for multiplying fractions is going straight across, right? We talked about that in PO10, yeah. So n times -5, our numerators, n times -5 is -5n. Our denominators, -5 times 1 is just -5. Well, you've probably learned before that anything divided by itself is 1, or anything in the numerator of the fraction can cancel out with the same thing in the denominator of the fraction. That's what happens here. -5 divided by -5 is just 1. And we still get n by itself. So when I said how this whole thing started, when I said that -5 times -5 cancels out, really what I was referring to was the fact that the -5 in the denominator of our original equation, because it is n divided by -5, when you multiply that by -5, being in the numerator of the fraction, that's where they cancel out. Long explanation. I hope that I didn't lose anybody with that, but that's really what's going on mathematically. Okay. The last one, n divided by 12 equals 35. If you don't want to write it out horizontally, you could also leave it, vertically. N divided by 12 equals 35, and then write your times 12, because we're going to be doing that because we're dividing by 12. The opposite of that is multiplying. Write your times 12 like up here. Just don't confuse it with the power, right? But multiplying by 12 there is showing that you are multiplying by 12 in the numerator of a fraction. Thus, it will cancel out with the denominator 12 in the original expression. N is by itself, and 35 times 12 is 420, I think. I'm going to go with it. Yes. Okay. And so we get n to be 420. And to check that, 420 divided by 12 equals 35. Yes, indeedy. Okay. If you want to write it horizontally, n divided by 12 equals 35. And you're dividing by 12. So to undo that, you're going to multiply by 12. These do cancel out because remember, they're in opposite parts of those fractions. And 35 times 12 gives us 420. So either way you want to do it, it's still the one step. You're dividing in the original equation. So to undo that, you're going to multiply. Okay. All right. I have no idea how long this video has been going. I forgot to check the time before I started. So I apologize if it kind of went on and on and on. But it's important stuff. Your homework is the backside, second page, sorry, of PO19, as well as the quiz that I gave you. The sooner you complete the quiz, the sooner I'll be able to give you feedback on it. So if you want to go through this homework and then do the quiz later on tonight, I might not get you feedback, whereas if you do the quiz now, it's not too many questions long, and then do this homework later on in the evening. But what you're looking for, again, opposite operations. I need to see the work. Here, I'll go over this one. I imagine if I asked for any for the board, you'd say the last one in the first row because it looks different. Remember that parentheses is just another way to show that you're multiplying. So you could rewrite this, negative 8n equals negative 56, no problem. Same thing here with this dot, right? Negative 11n equals 66. Those two things mean the same thing, a dot, parentheses, or whatever. So what's the opposite of multiplying by negative 8? We're going to be dividing by negative 8. Cancel those out. And you are dividing by negative 8. Okay, both the negative sign and that number want to cancel out here. And negative 56 divided by negative 8 is a positive 7. We can test that. Does negative 8 times 7 equal negative 56? Yes, it does. We've checked it. Life is good. Okay. One like this one, right below it here. N divided by 8 equals negative 8. If you want to leave it in vertical form, multiplying both sides by 8. Cancel those out of there. Opposite operations again. Negative 8 times 8 equals negative 64. Or if you want to write it horizontally, the opposite of dividing by 8, multiplying by 8. Right? Make sure you do it to both sides there. And we get n equals negative 64 that way as well. Right? I know if I asked for more questions, you would ask for this one, but I'm not going to ask for more questions. You can do it. Okay? Just follow the process. Even if you can't do it mentally, follow the process. Trust the math. Those opposite operations will get you to the answer. So, homework for tomorrow. We've got the rest of PO19 as well as the quiz, which has been posted in Google Classroom, so I can get the feedback, see how things are going. The quiz will be on both 18 and 19. And get that done tonight, please. That, folks, is how you math. Do not forget to like and subscribe, and have a great rest of your day.